All right. Good evening, everyone. Welcome to the eighth episode of our Salesforce MVP series with Jean-Michel Mougeolle from Paris, France. Thank you, Jean. And
Yeah, you're welcome.
and thank you for participating, guys, for tonight. And as usual, um, all there are familiar faces on our event today tonight. And again, we appreciate your time that you put in this type of events that we have here in the Philippines. And I know that you're busy with some stuff with your family and your work. And it's really important as well to give time to this type of activity. So again, we really appreciate your time. Um, for those who doesn't know me, my name is Neil. I'm a Salesforce MVP and I'm the managing director of MNL Consultancy. So yeah, go ahead, Joey.
Yep. So just to introduce myself, I'm the founder, principal consultant, and technical architect at Cloud Jedi Solutions. I'm also a leader here in the Philippines for the Trailblazer Community Group. I've been rated in the App Exchange as the #1 developer, and I've been in the Salesforce ecosystem for the past 12 years now. All right, next one. Next screen. So just to introduce our speaker for tonight, so he's the founder and CEO at SharingPix. He's also the Salesforce French User Group President and Salesforce MVP since Spring 15. He's also on the advisory board for cloud technologies and digital transformation for various companies, including ISP, startups, and so many more. So just to introduce our speaker is Jean-Michel, right? Cool. Let you take it from here, John.
Take it away, Jean.
Okay, so I'll share my screen. Cool, make that accurate. And there we are. So, I'm first of all, I'm very happy each time I can talk about Einstein Vision and all the others, and I hope that you're gonna enjoy that. So, the goal of of this is for me to make that very interactive. So, I have a spot at the end of the call to so in a little less than something like 50 minutes to go through questions. If ever you have a question that is really important because I have missed something, it needs to be in context. I'm sure that Neil and Joey can let me know. I may not be able to read the chat at the same time that I'm talking, but I hope you guys can do that for me if ever there is a very important question during the call. Anyway, no worries. You can collect that during the call, and I will be able to give you answers and chit chat with you at the end of the call. Don't hesitate also to join me on Twitter, on the SharingPix Twitter, or even my Twitter. You got the two handle there. I love to discuss it there, and I post a lot around images and especially images with Salesforce. So everybody see my screen? You see my slides? I'm good to go. Okay, so you can do a lot with Einstein Vision, but what I feel relevant first is to explain everybody what is image recognition about. So I will not try to do that much around API today. You can find a lot of documentation and so on. So, but you know what? It's going to computer vision and understanding what you can do with image recognition and all you can behave to have something that's going to be successful is really key. Calling an API, everybody can do it, and you can find a lot of things even just on the Salesforce documentation. But understanding why, and why it's not working when it's not working is maybe the more important thing. So today I'm gonna focus on that. Anyway, if anybody got a question around API, I will be able to find someone to be able to answer. We can do that at the end of the call or after that. So computer vision techniques is it's something that everybody knows about now. Just because you got a lot of things like going on. OCR was scanning a document and getting text is something that is very familiar for everybody. Um, Image classification, that what you got on Google search when you search for dog or for a cat. It's not because someone has tagged the picture as dog or cat that is get there. It's each image that you post on the website are automatically detected and automatically categorized by Google, as an example. 2D detection, you may use that with your camera when you got a tag somewhere that it detect on the camera that there is a code and give you access to that, or augmented reality. Object recognition, when you need to understand what is in an image, and 3D recognition, such as Face ID from iPhone, as an example, that detect parts that are very alike of an eye or the mouse, and combined things. Because, as an example, maybe you've experienced that. If you have received a speed ticket, maybe a camera has detected your car and reads the license plate, which is OCR, and that is working too good, maybe, or good enough for people not to drive too fast. But or emission reading is the same kind of thing. It's face detection and other stuff that permits to that permits to understand what is the emotion or what is the age of the person. But even if we are very familiar, this is based on different kind of things, and AI is based on different kind of thing. And you may have heard a lot about artificial intelligence, of course, talking about Einstein, but machine learning and deep learning. Just very quick intro for those that are not very familiar with that. Artificial intelligence is just like you want you want the computer to answer like someone who has a brain. And for that, the very first part was machine learning, where instead of listing the very limited thing that the computer can do, such as when you play or on Go or chess or whatever, you have limited things to do, and you have matrix that you can explain, or you react on this kind of context, but the context is finite, is already there. Machine learning is much more like, okay, we got this context, and if you give us some example, we may find out in the example something that is that we have to take in account. As an example, spam. What you can take in account as a spam is maybe the who sent that to you. It's pretty simple. So if you don't know the guy, then you point out to this guy that sent you spam, and you say to the machine, I don't want that anymore. And here it's the beginning of machine learning. So it's not really intelligent, but it's you give him example and explanation at the same time. So not only example, but explanation. So you explain him that spam is, then if it's sent by this guy, it should be a spam. You don't just show an email saying that this is spam, or at least in the old-fashioned way of doing things before 2010. Then there is deep learning. And deep learning is much more like you don't give an explanation. You just give examples. And the machine has to learn from the examples. Just like a 6-year-old kid will do if you show him cat and dogs. And at one moment of time, he will understand that this is a cat and this is a dog. Even if you don't explain him, oh, a cat looks like that, and you can recognize him by that, and so on. And so everything that we're going to talk today is based on deep learning and giving a lot of examples. And of course, you give a lot of you give a little of context, and you have to be sure that you make it learn good. Just give back the example of the 6-year-old kid. If you show him cats and dogs, and you show him a gorilla, and you say him that it's a dog, or you show him only black dogs and only white cats, and you show him a black gorilla, he may say it's a dog because it's a 6-year-old. He don't have the reference for that. Don't expect the AI to do better. Here, you give him example, and it's really important to understand that the example that you give, it's going to be the feedback that you have. So understanding the context and the way to go there is really super important to get a lot of good feedbacks. So image recognition, it started with machine learning. So when you want to recognize a stop sign like that one, first you were about to say that, oh, it should be red. You should have letter on it which are white. It should be something hexagonal, and you should have the letter stop. So if you can recognize those things in an image, it's more likely that you're going to have something. So that means that you have patterns that try to recognize if there is an hexagon. You have things that try to recognize if there is red, red spot, white letters, and so on and so on. So that's working well. But let's imagine that you're on a foggy day, then you recognize 100% stop sign in one way. And on the other, the computer will not understand it's a stop. But as a human, or even as a 6-year-old, you can detect that it could be a stop. Even if you're not 100% sure, you can say by 80 or 90% really look like a stop sign. So machine learning is not able to do that. So this is where the image recognition story start to go to this kind of description that is very precise, and you give him the explanation by something that is more fuzzy, that you have to give a lot of example. So it's much more like a neuronal network where you already have things that are going to be detected, a lot of things that are going to be detected: shape, color, letter, and context around, and all those kind of things will be part of that. So that means that you present an image and you make it learn from a lot of stop sign, and you will detect that on the lot of stop sign there is more likely something that look hexagonal in it. There is more likely something that looks red. There is more likely something that looks like letter, etc., etc. But it's just a probability. It's not a yes or no. When you give the explanation, most of the time is, do you detect that? Yes, no. And here it's much more like very fuzzy. So you push that in a neural network analysis, it gives you a score per line. And each line is just like a very tiny one. Is it red? Or does it look like octagonal? Is there something that looks like octagonal? And it doesn't answer yes, no. It answers, probability that there is something octagonal is 90% in that case, because you can detect that. It's red, 50%. I'm not sure it could be red. It could be maybe maroon or whatsoever, etc. Is there a letter on it? Oh, 10%. I'm not sure it's letter, but there is something that may looks like letter. So it's only 10%. And that, the addition of all those give a score. And if you give them the engine a lot of example, it may already have similar kind of scores, and it makes a matchup saying that, oh, it's look very like those scores that I have with stop sign, so that should be a stop sign. So this is where it can work. But remember that this is still very fuzzy. So for the machine, if you give him a lot of example, the machine could say that, oh, by 86%, this could be a stop sign. I'm kind of confident it will be that. But maybe it will say, oh, maybe that's a speed limit. It will not be sure. And because you give him some example, if within the same thing you give signs and candies on the same model, maybe he can come out with it that, oh, that's look like a strawberry lollipop. That a 6-year-old will say, no, it's not, because it's a road. I obviously can't understand that there's no big strawberry lollipop there. But the machine learning is just taking the example that he has, so it can come with something that is absolutely nonsense. Let me give you one example of that. There were those guys that has done a crazy app. So this app was, you can go out and take a picture of someone doing a sport without the context. So a soccer player without a ball, without the goal, without just doing one motion and wearing stuff. And he was giving you, oh, this is 99% a soccer player, etc., etc. So you were giving very, very, very high probability recognizing basketball player, cricket player, whatever you come with. It was phenomenal. And then one day, one of the guys who were very impressed about that just took a picture of his daughter brushing his teeth. And he come like, oh, this is a baseball player. Guess what? Because you do the same kind of thing like baseball players. And so why did he say that? Because he didn't have any example of someone brushing his tooth. And so what is the context on which you will apply the image recognition? What is the image that you try to recognize? What is the elements that you try to recognize? And then you have to understand that you have to accept that sometimes you get very bad answers just because it's a very tiny part of the world that will be recognized and very few examples. So keep that in mind. It's really important. Okay, Einstein Vision. What can you do with Einstein Vision? The first thing is image classification. So image classification, you just learn a lot from one image and you show the images. And when you bring one image, it gets the total context of the image. And you find if something, like as an example of this image, if it's sunshine, astro, or cloudy. So it gives you probabilities about if it is or not Einstein. Here, obviously, it really looks like Einstein with his big white hair and the way it used to be wearing the same thing, especially for a Salesforce character. So that's the first thing, the whole picture. Then you have the what you call multi-label. It's not very used, but very useful, that you can have the same image and you apply different class within the same model. And I say, as an example, I got the Claude class, an Einstein class, and each time it tries to recognize things based on this class. So with the same image, you can come with different probabilities for cloudy, saying that, oh, it seems to be a sitting cloudy here, but it seems to be also a sitting Einstein. I'm not sure about it, but there is a lot of white in it, so maybe, etc., etc. And at the opposite, you got object detection. And object detection will not only say that if there is something on the image, but you will plot and can count the number. So multi-label doesn't count if there is one astro or multiple astro. At the opposite, object detection will box each that are recognized and will give you per box a label and a probability. And this is maybe the more powerful and the more the harder to get work as you can imagine, because you have to give a lot of example of images in that case, less than in image classification. And what is new? You got OCR that is brand new, that is working already. So I say it's coming because I know that there is a long path of new features that are going to come. So right now you can extract text and tables, and it's very interesting. So please go for that. Take a look. Everything that we discuss here is available on API, is free, so you can try that for free. So that's good news. And OCR doesn't need any training, so it's just API that you can use. And there is also forms that permits to recognize from a form where you have written data and extract data. So it's really interesting. Go for it. And if you have question about that at the end or later on, just let me know. So how does that work? As I said, you give an example, and as an example, I want I have fridge, and I have to understand what is a fridge or a cabinet, and I have to understand if that's a 2-door, 3-door, or whatsoever. So you give to the data set a zip file where you have a lot of images in it, 3-door cabinets and 2-door cabinets and 1-door cabinets. And as soon as you have enough example, you can upload that to Einstein. And Einstein, we train the model based on that. So it will keep some examples outside of the data set. It will ask Einstein to do some training on that, and he will use the one it has kept, giving us examples in the, oh, do you recognize that? In you, what should be the answer? So do you recognize that? And if it starts to recognize at a good rate, it stops the training, or it keeps the training continuously and run more and more neural network deeper to have the finest way to do it. When it's done, you have a model with an ID that you can present an image to, and based on the image that you present, such as a 2-door cabinet, it will give you the probability of which data set scores it looks more like. So if we see something that is more like than a 2-door, it will say it's a 2-door. If it's more like than a 3-door, it will say it's a 3-door. And that could be just called by API. So it's based on Salesforce. You don't need to have a Salesforce instance because Einstein Vision is beside Salesforce, so you can make the recognition. You have app exchange tools that permits to do that, and I will let you know at the end the list of the way you can do it. But just keep in mind that even if you have a project without anything done with Salesforce, with an app on the Android as an example, and no Salesforce at all, then you can train that and work that. They don't have to buy Salesforce to get there. Okay. So there is already model existing, and they are provided for free. So you can use food image, and guess what? It's very precise. As an example, you can have as many example of pizza type that you want, so you can recognize different pizzas. So it's very impressive. General image model. So and once again, it's very precise because there is thousands of labels, and it can definitely know which kind of frog it is when you show an image with a frog. And scene, which is also very impressive. When you take a picture outside or inside and say you that it's look much more like a bedroom or a beach or a building and things like that. So it's really precise and really important. But most of the time, you want something that is very specific, very personal, and so you have to create your model. So you have to list images, and you have to be sure you don't make error why you do so. So the very first error that you do as a newbie is to use examples. So let's say cat and dogs. So I have, let's say 50 image of a cat and 50 image of a dog. And I put that on data set, one on the label dog and one on the label cat. And so I upload that, I train that, and I use one of the picture I use for the training. So one of the picture in the data set, and I ask Einstein if he recognizes. He will recognize it because it's the same picture. So you get the same score. So you get the same results. So you don't try to test with example, and try to test with things that are not exactly like the example that you give. Similar, but not very like. So if you take 2 times the same character within the same pose, but in just different directions, maybe it's not relevant to test with this. You will have a good answer, and maybe it's not because it has been trained well. It's because of very lack of something that is already there. The second thing is that okay, you try to recognize dogs and cat, and you have very few images with only cats. So you have images with cats and a mouse, and guess what? One day or the other, you will just show a mouse image, and it will say it's a cat because he got that, and that's it. So it's better, especially when you're in the image classification, to get only on the image the character or the label that you want to recognize. And 50 images is very limited. So you may want more images. 10 images is not sufficient. I will get back to the right number, but just keep in mind that trying to make something work with very few images is not a good idea. And variety is super important. Let's get back the example of the black dogs and the white cats. If you show a white dog, it will say it's a cat because white is predominant in the analysis. So it will have no clue that is not the color is not representative because you made it representative. And there is a lot of story around biases around that. So there were I think it's in America that they've made a hand dryer where you can put your hand, it detects the hand, and it starts automatically. So there were image recognition to recognize if there is a foot or hand and make differentiation. And guess what? Because they have trained that only with white people, it was not working with people with different color of skins because they were looking more like the color of the shoes than the white hands, which is not, it was not made in purpose, but that was not working at all. So it's really important to really try to imagine all the variety of data that you need, and that is really important to make something work. And so if you find something that is not working, let's say I got a dog, and when I put it, I got a very bad recognition. It's a good idea not to use that to train Einstein, but to keep that one and to try to find similar images to that one, and to train Einstein with all those similar and test if now it's better with that one, because you already have one image that is not good, that is not working. So keep that in, and don't try to make that part of the example that you're going to train in. Most of the time, it's better idea if you can afford that to do so. And the picture quality is very, very, very important as well. So resolution is key. You should not go for very old kind of resolution and very small. Uh, Light conditions, super important. You need to see the thing. So too shiny, gonna erase everything. Too dark, gonna erase everything. Reflection that put an image on top of the image is not good. And if you need to recognize someone, it's better to take a picture of him front than only on the side. And the same for any object. So if it's too angled, it's not good. But sometimes with bottles, you need to recognize bottles. You may need to have different version of it because you can rotate a bottle, as an example, instead of a license plate, which is always in front. And the example is not because you give a lot of examples that are not angled, that when you got something to recognize that is a little angled, it will not be able to recognize. It's better to give him the right shape at first, so he can really learn what kind of shape he can recognize. Then with something that is angled, he may be able to recognize that from there. And it's not because you want to be able to recognize also pictures in dark condition that you have to train with dark condition, because dark condition will make the learning fuzzy. At the opposite, when you're gonna show dark images, if you have things that are not done in dark images, it may recognize some shapes that will not have been detected otherwise. So number of pictures, it's super important to understand that. And there is a lot of different API on Einstein Vision, and I'm going to focus on the easiest one. So image classification. So if you want to recognize cats and dog, starting with 20 pictures each could be enough to do a demo. So you can go on Google, find 20 images from a dog, from a cat, and just create a data set from that. That will work. But that's going to work just for a demo. So frankly, if you need to do a demo, you can go for 20, but don't expect that to work all the time. So you may have to choose a picture to make it work. So it's working for a demo, but not for production. On production, it will not work unless it's so different. White dogs and black cats could work, but once again, you may have a lot of exceptions. So 100 plus is a sweet spot for image classification. So 100 sometimes is enough. Sometimes you have to go to 200. If it's something really, really, really tricky. So let's take an example. I want to create a model of one recognizing only cats and dogs. So there is so many difference between those two species that maybe 200 will be largely sufficient. At the opposite, I want to make a model that recognizes different kind of cats. Maybe 100 will not be sufficient because some kind of cats are very similar, and you may need a lot of examples so Einstein Vision can understand where to spot the differences, and that is very different. So the number to remember is 100. 100 per class that you want to recognize. If you want to recognize Einstein from Astro, from Cody, you should have 300 pictures, at least one in each part. Object detection. So you need to, here you are not talking about images, you are talking about example, because when you're gonna learn, when you're gonna make Einstein object detection learn, it will learn from a part of a picture. So within a picture, you can have, let's take the example of the characters, you can have characters that exist in multiple pictures. And it could be twice in the same picture. And you're gonna box one part of the picture where you see the character. And you would say that this is Einstein, or this is Cody. So once again, 50 to 100 work for a demo. It's more likely you will have bad answer there. 200 is then a minimum to start a pilot. And you will find that, and you will discover, it really depends on the context, that sometimes you have to go far after 200 because 200 is not sufficient because you have something that is a little too complex, and you have to learn from there. So don't be really surprised if you have to box more than 200 per label to recognize. So in our example, more than 200 for each character. Does that mean that I need, if I got 3 characters, I need 600 images? No, if you got 200 images and each time on each picture you got the 3 characters, so 200 images will be sufficient. But then you have to box and give to the box a label, so you need 600 boxes. 200 example of each thing that you need to recognize within a slot of images, and it really depends on the frequency that you will have there. So if a shelf display with a lot of bottles, you may need more picture than if it's something that you organize yourself and you put bottles next to, and you're sure that on each image you got all the bottles that you want to recognize. And that's true. More image you got, and the better the result is, because you will learn more and more. That said, going above 1,000 should not be relevant. At one moment of time, it start not learning more than that. So the use case for that.
Okay, we have some questions here.
Yes, please,
I guess before we proceed. So regarding, can we create a custom model for Einstein Vision? So I guess this is what we're doing. Am I correct? This is the model already, or not yet?
So yes, you can create a model, and this is what I'm talking about. Is getting a data set with a lot of images is the way to construct the model. So first you have a data set. The data set is just a zip with a lot of information in it, including per label the number of images, or per label the place where in the images you got the examples, and that is what this is all you're gonna create your own model.
Yep. And then we also have so when you say 100 plus to go to production, does it mean less than 100 would have issues with deployment? I'm guessing no, right?
So at one moment of time, depending on the context, Einstein can say, I don't have enough images, I will not create the model anyway. And that's very that's the case for object detection. It will just drop the class. So if you try to recognize a bottle and you got 4 bottles and 3 of them only have 200 plus, maybe the other one that gets only 190 will be rejected by Einstein. Einstein will say, I don't have enough things to be able. So that will not drop, that will limit the model to recognize only the one that have 200 plus. But that when you use Einstein API, it tells you what he has done, if it has dropped something. And yes, if you under 100 with image classification, or 200 within object detection, don't even think that you're going to have very good results for production area.
Mm-hmm. So then there's another one. How does one guide the model to learn only what we want to learn from the images and not things in the background?
Various background. That's the answer. So if you, it's always the same story. If you want something to be irrelevant, it should not be part of the image, or it should not be always the case. So I have an example. Someone one day asked me to do some recognition based on something that were handled in the end. And so we asked the people all the time on glasses, as an example of this one. So not to handle the glass all the time the same way. So with one hand, with one hand, with one hand, and then with one hand, and when with one hand. Give you a lot of examples. Because if you stick only with this, with the black one, and the white one is like this, guess what? The hand will be the more important thing. So if you want the background to be irrelevant, don't keep the same background on all the picture. Make a good variancy within the background as well.
And last one so far is how do the arrive at needs numbers? Any basis for reference? Is that based on your experience?
Yeah. So if it's just for you to play, just go on Google and Google search what you need to find, and download images and work with this. That should be sufficient. If you're in a retail area and you ask people to take pictures, most of the time the companies that want to do image recognition are already taking a lot of pictures. So ask them for the picture. That's the hardest part, especially if you have, let's say, 200 different SKUs to recognize. Then you have to make them give you maybe multiple thousands of images to be able to go through all those 200 and do a lot of boxing there. But that's their part. you can't go on the shops and create what a number of sales guys will be able to do. So this is definitely where you have to understand that uh, on this kind of project, you have one pod which is necessary giving the feedback about what is the context from the business use case and where you can find the images. And then you have to do your role, which is constricting things and asking for more images or more context to understand what is not working and how you can react based on that. So let's move forward. Use case, we just talked about it. A retail execution. It's a planogram automation where you take a picture and it just detects the different SKUs and do things is one. But also detecting the promotion that are used, such as all promotion should be not there. Part recognition, when you try to correct a problem within an elevator, maybe you have a part that could be taken in picture and then could be recognized automatically, and so you're sure about the part that needs to be done. Or defect detection. You got a tire that got a defect. You take a picture of the tire and it tell you if it's a crack, if it's a nail in it, etc., etc. And then auto labeling, you take a lot of pictures and you want those pictures to be categorized. So real estate, you take pictures when moving within a house, and you need to at the end to have images placed in the kitchen or bedrooms, etc. without someone saying so, because it could be obvious. But the next one is the one that your customer is going to ask for. There is no limit in those kind of use cases, and we have seen a lot of variants. So next in the in Einstein Vision is so it's already there. I used to call that enhanced object detection, which is what they call also V2 API and retail object detection. So it got all those names, but I prefer to use enhanced object detection so people can understand that it's based on object detection but get a better understanding. So within this API, it's a mix between image classification standards, where you just upload marketing images of a product, as an example, and then object detection data sets, where you also have a description of all the picture within the shelf area, plus categorization. So all the big bottles with big bottles, all the small bottles with small bottles, and all the cans with cans. So it can train image classification plus object detection, plays a model. So for you, it's going to be totally transparent. But then you will have to provide different kind of data sets and different kind of data, which permits to drop dramatically the number of images necessary down to 50, as an example. But it's just harder to get organized to make that. And that is only relevant when you have, as an example, different size of bottle, where it's work really nice. If you have things that are completely different, maybe you will have better experience and answer with object detection. OCR and form, I already talked about that, but that's really the future. So OCR is already there. You got the tabular extraction, and you got to have more and more. And that is working nicely on printed areas. So if you have anything that is printed, it's working nicely. If you have something that is written, or maybe just more graphic, it's not as accurate as what it could be, but they are still working on that. And form, it's something that should be available in Isina, where you can take a picture of a form that has been filled out, and you can extract data without the hassle of creating models. You will already learn from that. So if you want to go for it now, where should you start? So there is two parts. If you're a developer, just there is a lot of Apex API wrapper classes that has been provided. So if you search for Apex wrapper classes, you will find them. If you go on developer.salesforce.com or within Trailhead, you will have a lot of example. In Heroku, there is an add-on for that as well, and it's supporting all the kind of languages that you can come with. So it's just an open API. There is a lot of example classes that are already available. So just do a search. If you don't find it, you let me know. With that code, and even if you're a developer, maybe you're gonna be very interested in that. So you got a basic one that is doing the job of not using the. So if you're familiar with Postman, is exactly the same kind of thing that you can do with Postman to test a REST API. You will be able to do that with Einstein Vision Model Builder. That means that you have a zip file, you construct the zip file, you call that out, it will train, it will give you the API answers within a context in Salesforce, and then you can play with it. And you can see how it works. So you don't have to code the call of the API, but you will have to provide all the data before that. So it's very similar to Postman for me. But you can't use that to get organized to create model down the road. So you may have to create your own tool to get that. Or it's not because I'm from Sherpex that I'm saying that, but we have an app on the App Exchange that permits to do that. And this app is much more like the Copado of Einstein Vision, where you can manage a lot of models. You can manage a lot of images. We don't store the images. We store the images for you. You don't have to store them into zip file. We resize the images automatically, so they are the right resolution, all at the same resolution. We do a lot of optimization, and we detect when there is something that is going wrong and prevent you to call the API on something that we know could be modified before you train it, because sometimes the training can take 2 days if it's very complex. So we do this kind of thing, and that is also available. So if any of you want to try that out, let me know, and I will see if I can give you an access for free on that, depending on the kind of use case that you have. And but that's available on the App Exchange. It's much more like if you're going pro, just keep in mind that there is at least one app on the App Exchange that permits to do all without having to go through all the complexity of making that happen. So if you want to learn more about that, there is many places. First of all, I love that shortcut, Einstein.io. It gives you a lot of documentation, very good reading there. Don't hesitate to go there. There is also traded.einstein.com. So you've seen that. I'm an Einstein champion. So that's a program that they're going to be transformed into something else that they call platform champion, which is going to be divided into Einstein champion and so on. But this is where we've proved that we have everything that is needed to understand, plus all the experience that we have. And there is more and more Einstein Vision partners. Of course, Sherpex is one of them. And we have provided that to many very, very big companies in various contexts. If you want to learn more, don't hesitate to talk to me as well. I will be very happy after this to keep the discussion going and to give you insights and about the difficulties and the time that you have to spend on that. But definitely Einstein.io and traded.einstein.com plus App Exchange is the right place to learn more. And now you can learn more by asking me questions. So I know that you've already asked it. I hope that it was sufficient for you to understand what it takes to start. But I'm pretty sure that I have not covered everything. So you may have a lot of questions. That's good time to ask them. So do we have questions, Joy?
Yeah. All right. So let me just go through it. So what would you say is the edge of Einstein Vision versus many other image recognition solutions?
Okay, so Google Vision, as an example, is more generic and it's very hard to train unless you are a data scientist. Einstein Vision is much more like to be very powerful as soon as you are less generic and you try to do something that is precise for a customer. Something like recognizing different bottles of Coca, as an example, or Pepsi or whatsoever, could be done faster, better, and get the right answer by what you've created. With Google Vision, it's going to be too harder on one side or too generic on the other side. It will not detect what kind of Coca bottle it is because it may not know what a Coca-Cola Zero is at this time, or what the new Coca-Cola flavor is. But you can train that model on your side very easy on Einstein Vision, not on Google Vision. So if you try to do something that is very generic, you already have models that exist with Einstein that you can use. And you also have other tools. I'm saying Google, but there is many that's going to give a lot of good advices. The main thing is, do you want to train things by machine learning? and this is super important to understand that deep learning machine learning is something that you can have access to through Einstein Vision training, because they already have done a lot of work by creating all those kind of neural network that permits to recognize different part of images. So, and that's going to be trained in a very, very accurate way. So it's really amazing the kind of, if you know what you do and you do the right thing, it's really amazing to see how accurate you can have an answer. It's amazing. The other tool will be too hard to go to that point unless you're a specialist, a data scientist, or will be too generic and will not fit exactly your needs.
So you mentioned earlier that we have a free version of Einstein Vision, right? Are there any specific limitations that we have to be aware of?
So the builder is something that you can install from the App Exchange, and you just have to create zip files and start working with that. With image classification, it's pretty easy because you just have to have the right kind of resolution of images, and if everything is JPEG, it's going to be working. So it's not very big constraint, and you will be able to upload a zip file with folders, and in each folder name will be the label, and all the images will be there. So it's pretty easy to create first the data set. And using the model builder, you just upload your zip, said you want to train a model, and it would do it. And that is for free. And the API that you can call, if I do remember well, you got something like 4,000 recognition per month that you can use without paying. So it should be enough to do the training, to do the test, etc., etc. But as soon as you go in production, 4,000 is nothing. I mean, if people are asking about that, 4,000 makes something like 200 per day, and 200 per day for an industrial way, it's nothing. So you will have to pay for the API there. There is one API that lets you know how many API calls you have left, so you can also know where you are. There, and you should be good to go for everything gratis. You go on the developer org, you install the App Exchange, the model builder, you construct the zip file, you upload them, you play with it, and everything for free.
Yeah, cool. So can Einstein Vision detect multiple objects and understand their size relative to other objects in the photo?
So that's a very good question. Einstein Vision is the dumbest version of image recognition you can have. So everything that you would like to do on top of boxes that has been recognized, you have to do it yourself. So that means it will recognize different size of model. It may recognize by the shape that they are different size, but if they are exactly alike, then you will have to make the difference between all the size. Plus, you have a probability that you can play with. It's gonna be, there is more likely good answer if you train him with a lot of pictures where you have small buttons and big buttons next to it. He will understand that from the example that you did. And within the probability, he may say 40% it's a big bottle, 30% it's small bottle. And then you know it's not the right answer. You may get fuzzy there. But if you get 90% is a big bottle, 10% is a small bottle, then you have your answer. So playing with those two things, giving a lot of examples, will give you that. But if you're in a context where Einstein Vision can't detect that, it's not a big problem. You have boxes, so you can cut that. If it's a small box and the other one is a bigger box, guess what? The other one is a big bottle and the other one is a small bottle. Especially if you have other on the same picture that you recognize, that you know it's the same size of the other box. Don't expect Einstein to do things above things that has been recognized. Not yet. Recognize with box, that's all that Einstein Vision does for now.
Cool. So another one is, does training a model require an extensive usage of resources from your local computer, or will be handled by Salesforce?
No, okay. It's done by Salesforce. So it takes two days to be trained with complex things, very complex thing. Most of the time, it's just like 1 hour, and you got the answer. Sometimes minutes, but that should be just an image classification with very few images. But you can expect 1 to multiple hours if you go very complex, multiple days. But it's only done on server side by Salesforce and Einstein Vision engine.
For that few minutes or hours, how many images would that be? So there's a question: how many? Let's say if we're doing 200 images, how long would that?
Oh, so 20 images should be minutes. If
Okay.
let's say 20 images with 5 classes, so you need to recognize 5 things, should be minutes. 1,000 image with 10 different things could be 1 to multiple hours, and 200 different objects with multiple thousands of images could be multiple days.
I see. So that's the complexity there. It's basically many types and many kinds.
Yeah,
in a sense.
and it's kind of exponential, because the more example that you need, the more class you need to recognize, the more tricky it's going to be. So you have to understand that it's a loop that Einstein is doing. As I said, you're going to keep some images, not training with them. You're going to make the training, and you're going to try, okay, I have done 3 loop where I am right now. So this should be a coca. Does it recognize as the coca? What is the probability? It's 80%. Oh, 80%, I don't want that. It's too low. So he will do 1 more loop. That means that he would say, oh, go deeper. Analyze the picture deeper. And it will train like that again and again and again, until you reach 90%. I'm saying 90%, but I don't have any idea about the number, but just to give you an example. And so it could be looping at one moment at a time. It will say, oh, that's enough. I feel like I should not be able to do better. But that can, so that's why it's exponential, because the more you have, the more complex the context will have, and the more things you have to do. So the two metrics will be multiplying the things, and that can become, so before it starts to be too high, it will cut, saying that this is going to be, the next loop going to be too much time, not acceptable. So I will cut that there. So I have not seen a model that took more than 1 day and a half to work. So multiple days is much more like more than 1 day, but 2-3 days, it's not likely something that you should have.
All right. So what happens when the image does not match an existing classification?
So he finds something anyway. That's a probability. So you have cats and dogs, and you show him a giraffe. It will tell you what the probability the giraffe is looking like a cat. But unfortunately, it will not say that. He can say there is no chance it's a cat, but there is similarities anyways. It got eyes, it got legs, so it will come with a probability, maybe a low one, but a probability. So with this, you can have a threshold under which you will say it's not recognizing at the good rate. So maybe it will tell you it's a giraffe. This giraffe is a cat by 20%, and you may say, okay, it's under 50%, so I will not accept that answer. Is not sure enough that it's a cat, so it should not be a cat.
Cool. So how can we train the model to differentiate between living and non-living objects when they are exactly the same in shape and size? Example, a mannequin versus a human being.
Oh, I don't think that you can make difference. Examples is most of the time the right answer. So if there is anything which Einstein can detect at the end from something visual, but once again, the good example is a 6-year-old. If you can explain to a 6-year-old, if you can show him and without explaining him, the 6-year-old can understand what is it with a still image, maybe you have a chance that Einstein Vision will do it. If you have to explain what to look after and why, the more you explain, the less Einstein Vision will be able to recognize.
Right. Cool. And then I think we have one last question. So does Einstein Vision have a pre-trained genetic model, or does one
Yes.
have to start from scratch?
Now there is a free models I've told you about: food,
Mhm.
general, and scene. That's something that you can use right away. So it's just an ID. So normally when you start to train, it will get back to you as soon as it is trained by giving you an ID, and you can use the ID by the API. Say, oh, with this ID, I want to recognize this image, and I want the result. So
Mhm.
instead of using the ID of things that you've already done, you already have as global the IDs of those three models that has been trained for you. So you can already try that. It's very impressive. So please go for it and do your job. You will see the answer there.
Mhm. Okay. One last for me then. Regarding sharing pics, I know you've been in the app exchange for a while now. One use case that I see every now and then is basically scanning documents, right? Of course, it's Salesforce. Some companies are still using pen and paper. And it's, let's say, scanning and then automatically recognizing corresponding document to attach to. Is that something that sharing pics also helps with? Is that right?
Yes, so that is based much more like, so it's not, it's partially image recognition. It really depends on what you want to do. So what is built in Sharing Pics, as an example, we have a mobile app that comes as a companion of the Salesforce mobile app. So you can in context open our app, which permits to take pictures of documents, which, the smart scanning that detects the edge of the document that you have. So that's going to be the first trick. Then do a scanning version. Then do OCR to extract the text and make that available within Salesforce with as a PDF, coming with a text extracted if you want that, or just an image if you'd like to. On top of what, Einstein form will be able, if you always get the same form with at the same place, a label, and then a text that has been typed or entered, it will be able to detect what is, as an example, passport, what is before that, which is a name, and what is beside that, which is Mougeolle, my name, as an example. And we'll be able to extract that. So the two can work together. SharePix, the idea behind SharePix is to help people to be able to manage images within their Salesforce, or to take them, make that available, and then or to make automation based on that. Einstein Vision is just one of the automation that you can do based on images that has been uploaded. Another automation could be resize them and make them part of a PDF that's going to be sent by email, or make them collate into a rich text field because you need to send that to have that on the report, or maybe an after and before that needs to be side to side because you want, when you go there, being able to compare all this kind of automation that you would like to do. Because we are in the Salesforce world, we provide Salesforce data that permits to do that. Then extracting, we may rely on Einstein form to extract data, or Einstein Vision to recognize images. That's the second life of the image. It's not the first life is, oh, I take it, or I store it, or I make it in context. Then you can apply things such as Einstein Vision or Einstein form detection or Einstein OCR to extract text on from there.
All right. Cool. So, okay, we have one last question. So, great use case. Does that functionality work well with under standardized documents like invoices?
Yeah, so with invoices, what we've done, we have a great example that we've trained Einstein Vision image classification to recognize if the invoice is coming from Microsoft, from SAP, from Salesforce, as an example. It's very easy. You just can hundreds, and you may have hundreds of those already, and you make image classification work, and when you upload the picture, then it will tell you, oh, that's a Salesforce one. And because it's a Salesforce, you know which area you have the invoice number or the PO number. You know where it is because it's always the same place. So you can work on OCR just on that and get a very accurate recognition and extraction of a text because you know the context. And we've done that with a customer that has automated all the pictures that were, all the invoice that were scanned to put that in Salesforce in the right account. and get the PO extracted when needed to do a match between what was expecting as an invoice and if the amount is accurate. And that was working nicely. It was just amazing, just because of those two things together: Einstein OCR on one side, but on the right place, and the image classification on the other side.
Awesome. Thank you so much, Jean. Do we have any other questions? I think not. John, we do have 6 Trailblazer backpacks. They had the opportunity to ask you a question. Maybe you could ask them a question as well, and then let's give them to whoever uh, can answer your question. Then we can give them a prize, a Trailblazer backpack. Like, do you have like 3 questions based on your presentation?
Yes. So the first question, and that may be a quick one. How many picture is required for
It will be the
image,
first one.
for image classification?
Just answer in the chat.
Okay.
All right. Anything else?
No,
So
we are having a quick quiz.
yeah.
So Jean will give questions, and then whoever got it first will receive a prize from us.
So that was the first one. Do you want to go for the second one?
Yes, please.
Okay. How many uh, existing model do you have within Einstein Vision that are already provided? Yes, obviously freeware is the right answer. Pretty cool. I see that people get a very good get a very good understanding about that. And last but not least, who is the Copado of Einstein Vision on the App Exchange?
Sorry, what's the question, Jean?
Who is the Copado of Einstein Vision available on the App Exchange? Yeah, I see that Prabhat is a good listener. Pretty cool. Pretty cool. Wonderful. So I hope you guys do you need one more, or is that good?
We will give away the 3 Trailhead backpacks using a raffle, a back race. Do you have that prepared, Joey?
We don't hear you, Joey. You're mute.
Yeah. Sorry. I don't have the list yet though. So
Okay. Yeah, well Joey's doing that. I'll just share my screen, and then by the way, thank you so much, Jean, for your time
My
today. We
pleasure.
really appreciate it.
My pleasure.
Mhm. And hopefully we will have an in-person event next year so that we could invite you here in the Philippines.
I would love to come. I would love to come, definitely, and meet everyone in person. Just keep in mind, everyone, that let's keep the discussion going. That's my way, and I love that. So don't hesitate to go on Twitter and ask me for more. I will really be super happy about that, and we can do that after.
Awesome. All right. Thank you again, John.
Thank you. Bye bye, everybody.
yeah. Thank you. Yeah. I'll
Bye-bye.
stop
Bye.
recording then. Thank you.